First of all, I want to thank everybody for coming. It's a really big crowd today. I'm really excited everyone's here to see this talk. And thank you very much to the organizers of this event for having me. I'm really excited. I was actually born in Texas, and I have a lot of family that lives here, so I'm really happy to be back here. It's a great opportunity. I have a Texas joke. Make my one Texas joke at the beginning. How do you know someone's from Texas? They'll tell you. So you can all go home and say you went to Texas and you met people from Texas because they told you. I'm Blithe. You can find me at Blithe on Twitter and GitHub, and I'll be here all night. Thank you. I work for a company called Fastly. Fastly is a real-time content delivery network, or CDN, and we help businesses scale their websites, mobile apps, and APIs. We offer instant purge, real-time stats, and complete configurability. And I help work on the configuration APIs. The reason I'm talking so much about them is because they afford me the opportunity to come and give talks like this at conferences. And I'll be happy to answer any questions about Fastly after the talk. So we're really here to talk about microservices. And I want to do a little bit of an intro to start with. Because I've actually met several people who haven't even heard of microservices. Microservices can be understood in contrast to what people might call a monolith. So historically, all of the server-side logic used for retrieving and manipulating records from a database was all stored in one single application. And as those applications grew and grew over time, and they just added code and added logic, they started to resemble a monolith, a large, complicated block of code. In contrast, microservices take that application logic and break them out into smaller pieces, smaller, isolated services that can exist independently. So that's a small or micro piece of functionality of your larger system. And really, if you want to learn more about microservices and the monolith and what all these historical architectural patterns, Martin Fowler and James Lewis wrote a great collection of articles. You can find those at martinfowler.com. They've written it much better than I could ever write it, so I would really recommend that you check that out. So why are microservices so popular? Well, they provide several advantages over a monolithic architecture. First of all, they provide independent deployment and scalability. So for example, with a monolith, you would have all of your logic in one application, and you would deploy it on one server. And if you wanted to scale up, you would add servers. So you're adding duplication of that application. For microservices, in contrast, you can scale up as you need. So not everything has to be duplicated. It allows you to deploy just the parts that you need. So instead of deploying the whole application every time, you can deploy one little piece at a time. What's nice about that is instead of having to wait for a deployment schedule, maybe once every 2 weeks or once a month even, you can deploy pieces when they're ready. And that moves you towards continuous delivery of features. Oh, even bigger. Another advantage of microservices is it allows you to compartmentalize your teams and responsibilities. Small services allow teams to focus on small parts of the larger application. They don't have to know about all of the UI layer and all of the backend layer and everything of the application. For example, your user experience team can focus on your user interface layer without having intimate knowledge of your backend logic at all. For example, the Fastly UX team builds just front-end JavaScript applications that consume the API. So it allows us to separate those teams from each other. There's also a phenomenon called Conway's Law, which is that your architecture will resemble your team communications over time. I recommend reading about that also. Microservices also allow technical design freedom. So you can build parts of your application using the technology that's best suited for the task that you're interested in. Like I said, the UX team builds JavaScript front-end applications for the UI. You can use Ruby or Python for your API layer, since there are nice frameworks for building APIs in those languages. And for things, maybe you need faster processing for maybe real-time data processing or something. You can use Go or C, a much faster language. And I want to point out here that you don't have to make different services based on different languages. It doesn't have to be as different as that. You could make a different service in the same language, but using a different framework, or maybe just a different version of the same framework if you needed to. It allows you to choose the technology that you need. Microservices also offer fault tolerance. Previously, when you deployed everything all in one application, if one part of the logic was broken, your entire system might be down. And we've seen this before. Whereas with a microservice, maybe one small service is unavailable, but all of your other services are available. You can gracefully handle this service being unavailable and go on delivering the rest of your application with no problem. Now, I also want to point out here that microservices don't automatically give you fault tolerance. You still need to build your application in a way to handle when those services are unavailable. But you can do that in a graceful way. So why me? Why am I here talking to you about this? I actually have several years of experience working on service-oriented architectures. I started as a consultant. I work at Fastly now, and I also helped in one of the biggest launches of my career. I helped launch HillaryClinton.com last year. So I have actually a lot of experience with high-traffic production SOA systems. And so I have experience, but what really is experience? Experience is really about making mistakes and learning from them. But the good thing about experience is that you can learn from other people's mistakes. And that's really what the rest of this talk is about. I'm going to tell you a series of stories, and these are mistakes that I've made over my years of using microservices. And you might think, as I'm telling these stories, these are just human error. You know, of course things like that are going to happen. But you could argue that these errors were magnified or happened because they were in a microservice architecture. And had we been working in a monolith, they might not have happened. I also want to point out that not all of these stories are from Fastly. They're from over several years of experience. So the first story I want to tell you about is we had a new feature request. Our API was supporting a content type JSON. So all of our responses were returning a JSON content type. And we needed to support a new content type, which was JSON API. So if you looked in our application, in our service, we were just saying, hey, all these responses are JSON. Just like this, all of them, default, JSON. And we decided, OK, we shouldn't write JSON response for all of them, OK? If we set a content type, I don't want you to overwrite that. So only set it to JSON if I haven't already set it. OK, cool, right? No problem. No problem, no big deal. Boom. So this actually resulted in errors in production. And you wouldn't think, you know, what happened? And of course, it's not as bad as this image makes it seem, of course. But I personally take errors in production very seriously. So when we made that change and pushed it to all of our tests passed locally, everything in my service was passing, all the continuous integration said, yep, good to go, ship it. So we shipped it. But when we did that, the front-end application was unable to process those API responses. And the reason was because sometimes we were returning a content type text HTML. And this was bad, as indicated by the sad emoji face. Because the front end didn't know how to handle a content type of text HTML. It only knew JSON or other variations of JSON, including JSON API. So we thought, how did this happen? We didn't set this. We didn't set text HTML. We were using a framework, Sinatra. It's a very popular Ruby web application framework. And so we dug into it. Maybe Sinatra's doing something. So we dug right into the test suite of Sinatra, and it says, almost in plain English right there, it initializes with text HTML, content type. So we thought, okay, what? It's going to default to content type text HTML. And right there, you can see it's setting. Headers either use the content type header that you're setting, or default to text HTML. So previously, we were just overriding everything to be JSON, so it never got to this part where it set it to text HTML. But since we stopped doing that for everyone, it resulted in it falling back to this default. But what's the real problem here? Obviously, that was a bug. We didn't catch that bug. The real problem here is that this API service broke the contract that it had with the front-end service. It made a change. It wasn't returning JSON responses anymore. It was returning something else. And the front end didn't know how to handle it. Now, how could we have prevented this situation? As I mentioned, the tests were passing. The API tests, all of the tests, great. Everything looked good to go. I might argue that this might not have happened had the front end and the back end, all the API, been in one monolithic application. You probably would have noticed this. Your test suite probably would have covered the front end and the back end. And you would have noticed this sooner. Because we had separated those teams and those test suites, it wasn't caught. So one way you can get around this is by using continuous integration. If your front-end application has a test suite, you should run it against your back-end API. You can do that maybe in a staging environment to where you point your continuous integration test suite towards the staging environment or something like that. You might also argue that a QA team might have helped. I know not all organizations have QA teams, but maybe had this spent some time in QA, that might have prevented it also. So the next story I want to tell you about is removing a feature flag. So this is a pretty simple story. But first, let's start. What is a feature flag? Maybe you haven't heard that term. Feature flag is a commonly used tool for gradually releasing features to a certain set of users, so sometimes one user at a time. So it's usually a flag that you can toggle in a UI. So an admin user might change this, turn something on or off for a specific user, and it changes the behavior of your application for that user. And it might look something like this. Say you have 3 services that are all going to use this feature flag. So first you have the UI that presents the state of the feature flag. So does this user have this feature turned on or off? So it needs to know about the feature flag. Then you have a second service, which is in charge of controlling which user has the feature flag turned on or off. It holds the state of the feature flag for a user. Okay, so it obviously needs to know about the feature flag also. And then maybe you have a third service that, based on whether a user has a feature flag enabled or disabled, it changes the behavior of the application. Okay, so instead of returning all 100 of these results, I just return 20 or something like that. So all 3 of these services need to know about the feature flag. So say you want to remove the feature flag. Cool, we're just deleting code. It should be so easy. You just slash and burn it, you know. But with microservices, you've now spread this code across 3 repositories, or more sometimes. So making the change, actually making the change to remove this feature flag requires 3 different pull requests in 3 different repositories. And then to roll out that change, it's going to require 3 different deploys to production. And maybe you have more steps in that process. It requires a lot of overhead. Someone needs to be thinking about what order can we remove this in? Have all 3 of these repos been accounted for already? Has it all been merged? Has it all been deployed? Someone has to hold that in their head and be tracking that. Maybe you have a project manager or someone to do that. And three is pretty simple. Maybe I can do that all in one, in an hour, if I'm lucky. But what happens when you have 50 services that need to be edited, or 100, or 500, like some of the larger companies like Netflix? It becomes a lot more overhead. So isolating services into separate repositories, it may speed up your deployments, but there's definitely an additional overhead for managing all of the code across those services. In real life, it's going to require communication across teams. What if each of those services belongs to a different team and you never work in those, or they're in a different language and you wouldn't even know what code needed to be deleted? You have to talk to the other teams, and someone has to communicate those changes, and someone has to be responsible for that. You can do that with a very good management team. Maybe you have an excellent project manager or product manager who's that's their job, is to just track down what's done, when is it done. Maybe you have a really fast release process. So you can make all these changes, everything goes out automatically, it's not a big deal to make those changes. And maybe it's easy to deploy also. Maybe your deploys are a breeze. But the real question is, can your organization handle that overhead? And is it worth it to you? The third story I want to tell you about is about tightly coupled services. I feel like this is one of the most common mistakes for a microservice architecture. And I've also seen that to be true. So say you have 2 services. You have service A and service B, and service B has a database. And service A is responsible for presenting those objects from the database. So it has to always talk to service B to get those objects out of the database. So they're very tightly coupled. A has to talk to B to get the information out of the database. And when you have this architecture, when you have this where 2 services are tightly coupled, it's headaches all the way down your deployment stack. So let's start with production. Say you have your 2 services, A and B. Service B goes down in production. Service A goes down in production. If service B doesn't exist, A can't exist. And you'll sometimes get in this cycle where A keeps asking, B, where are you? B, where are you? I need you. And sometimes, if it's really tightly coupled, B will also be asking, A, where are you? Where are you? And they just go back and forth in this cycle, and it's a disaster. So that's a pretty obvious pain point there. You obviously don't want production to go down. But this is true also in development. Because when you have 2 services that are too tightly coupled, they can't exist in your development environment without one another. So if you're going to develop on one of these services, say service A, you need to have service B up and running and service B's database all set up. So maybe that's okay. Maybe those services are very similar and it's easy for you to spin those up right next to each other. But what if these 2 services are very different? What if your team is only responsible for one of the services, service A? And you know about that code base, but you don't know anything about service B. But yet, you still have to have it in your dev environment. What happens when service B is broken in your dev environment? Maybe somebody pushed a bug, or it's out of date or something, and it's broken in your dev environment. And you can't work on service A because service B is broken. and you don't know how to fix it at all. There's another cost there. What if those two services are very different? You need to have a dev environment that can handle both of those services existing in your, maybe on your local machine or whatever your dev environment is. So you probably need a good ops team. So maybe you have a lot of services that are coupled together, and they're all different. You need to have all of them running for your one service that you want to work on. And that's true. That's also true for production. You probably need a good ops team to be able to deploy all these services into production and have a good production environment where they can all exist. But it's less obvious for the development environment. There's a need there also. So when you have this architectural setup, it leads to a lot of developer pain, just day-to-day trying to work in the dev environment. And that also results in a pretty high learning curve. Say you have a new developer who's a junior developer, they're new to coding, or maybe you have an experienced developer who's just rolled onto your project. There's a lot of time to figure out, how do I work in this service? How do I deal with this other service that might be broken and I don't know anything about it? So there's a lot of pain there. This is also true in your testing environment. Maybe you might consider this the same as your dev environment, but testing headaches are a little bit separate from your dev headaches. So again, we have our same tightly coupled service, A and B. Say you want to run the test suite in service A. And because it can't exist without service B, your tests also have to run through service B and interact with the database. So this requires a lot of test setup. You have to set up all of your tests for service A, any environment changes that you need for service B, and anything in your database also. When you have it like this, you also can't run tests using continuous integration when you have to do all this setup of multiple services. So things like Travis CI or Jenkins. When two services like this are too tightly coupled, you have to run your tests inside your dev environment. You can't offload it to the cloud. And that means your devs are spending time running tests on their machines, and they can't go on to work on something else. So that takes time. There's a cost there. So one solution, you might think of maybe VCR recording. Now, how many people have used VCR? All right, most people, but some people didn't raise their hand. OK, I'm not talking about that VCR. I'm talking about a Ruby library. There's a VCR gem that you can use. And it's a library. It's open source. You can go look it up. It's a library used to record your test suite's HTTP interactions between services. And so you can record them in one test run, and then you can replay them in another test run. So your service is no longer reaching out to that other service in your test. Now, I think this is meant more for external services like payment providers or things with very complicated responses that you wouldn't be able to fake in your test suite. And I think that's an excellent use case for something like this VCR gem. But in the case I'm talking about here, where you have two tightly coupled services, and you're in charge of both of these services, it's less of a good test case there, because when you try to record all of your interactions between A and B, and almost every one of your tests has an interaction between A and B, you're having a recording of almost every single test in your test suite, as opposed to if maybe you just have one controller that talks to your payment provider. Those are very few recordings. So when you have this situation where every single test in your test suite has to be recorded, then you get in a situation where every change that you want to make, every pull request has changes for these recordings. And what do? Maybe you have 2,000 different recordings now. How do you manage those? Do you commit those right into your repo? Do you bundle them up into a tarball? What happens when you have 10 PRs and they all have changes to this tarball with the recordings? Then you have to deal with the complex, and it's a nightmare. And maybe you're imagining like, oh, I would never do that, but I have actually been in this nightmare. So it's real, it happens. So what is a possible solution? What would I recommend? First of all, don't build services that are so tightly coupled that every interaction, every test interaction has to go between the two services. One option that I would recommend, if you have two services that are constantly interacting, or if you have many services that need to interact with that one service, you can build a client. And what you can do is you can push those interactions, the contract between the two services, into the client. So you can define how these two services interact, or how other services should interact with your one service. And what's nice is you can build your real interactions right next to mock interactions, so that you can run your test suite both against the mock interactions and against real requests to see if things are still working. One library that I recommend is called Cistern. It's also an open source library, and it's helpful for building Ruby clients. It's a nice framework for building Ruby clients. So here's an example. I have an example of this one. This is a client used for interacting with Pivotal. And so maybe you wanted to get a project for your Pivotal project. Go get my project. So inside this client, you would define a real interaction. How do I go get this project from Pivotal? And right next to it, you define a mock interaction. So in this one, instead of actually going out and making the request to get the project, it's stopping that and using a local data store, so self.data here. So you can set up a mock interaction, and you define it in the same place as you define the real actions. And what this allows you is to both run your test suite both with real interactions and also with mock interactions right next to each other. So this is something I recommend, and this is solve problems. This also allows you to say you have 10 different services that all need to interact with this one service. You can use the client in all of those places instead of having to duplicate that interaction code across all 10 services. So it's a really nice way. So the last story I want to tell you about is probably maybe the worst mistake of my career. You're all getting it. I'm just bearing it out there. And again, I would argue that the microservice architecture contributed to this. So let me paint the data model for you. So you have a family, and in that family you have many people. Okay, so several people, maybe up to 10 people. But then each person also has many pictures. Say people, the people in this family they like to take a lot of pictures. Each person has millions of photos. Great. So I'm working on the API team, and there's a separate front-end team. And a common request that I get from a front-end team that is consuming an API, they want me to build an endpoint to rule them all. An endpoint that will allow them to edit multiple objects, multiple nested objects in one request. They're tired of making, 20 different requests to get all these different objects and the state and what's happening. So they say, why can't you just build one endpoint that allows me to update or delete or create objects, nested objects? And so maybe at least one time you say, yes, okay, I'll build this for you. I'm in a hurry. I know it will make your life easier. We're in a hurry to ship these features. I'll build this endpoint for you. Cool. So here's an example JSON blob that the front end might send as part of this request. Okay, so you see you have this parent object, which is the family. And then nested under that, you have people, and you have two people here, Sally and Bobby. And say you wanted to delete one of the people. This is the current state of interaction. Say you want to delete one of these people. You might send a different JSON blob. Okay, so now you see Bobby's not in this JSON blob. So the backend says, okay, something has changed here. Let me go look up the family. Let me go look up what I have in my database. Well, I used to have two people. I had a Sally and a Bobby. And you're sending me this new JSON blob, and there's no Bobby. Okay, you must want me to delete Bobby. Okay, great. Cool. So, you know, when it works the way you want it to work, that's great. That's great. So the front end sends a request like this. And the back end is expecting a request like this. I'm going to click back and forth a couple of times. Does anyone notice the difference? The front end is sending IDs as strings, and the back end is expecting IDs as integers. This small change, sending a string versus an integer, resulted in, I'd like to say, catastrophic data loss. And it happened twice. So we repaired it, we fixed it all up, and it happened again before we figured it out. So what was happening? Well, timeout, first of all. Let me just say, we had database backups. All of the data was not lost forever. It was only lost temporarily, but it took a lot of work to get it back in a good state. So let me give a plug for backing up your databases at a regular interval. I mean, I might have gotten fired probably, maybe, I don't know. So what happened? The backend needed to look up the people in the family. So it needed the ID. So when the front end passed a string, or two people with strings, it said, I don't have any people in my family with strings. You must want me to create those. Okay. And then it said, I was expecting two integer people, a Sally and a Bobby with integers. And you must want me to get rid of those people. So you got two new people that are exact copies of your two old people. Except they're strings instead of integers. So why is this so bad? You know, they're copies of the same people, might not be so bad. If you remember the data model, when you destroy a person, you destroy all of their pictures. And remember, these people had millions of pictures. So when it deleted the old people and created the copies, which were the new people, the record of the pictures was completely lost, except for in those database backups, which, thank goodness. Thank goodness. Okay, so what is the problem here? How did microservices contribute to this problem? There was a poorly defined interface between the API and the front end. The front end thought, it's cool if I send you strings, right? It's no big deal. And the back end thought, no, you have to send me integers or I won't know how to find the people in the database. So there was a strict back end requirement, very strict. So maybe loosening that requirement, allowing the back end to accept strings or integers maybe would have been nicer. Another issue here was what we call a hard delete versus a soft delete. And what that means is when the people were deleted and the pictures were deleted, they were completely removed from the database. Maybe that would have been solved by using a soft delete, which means instead of completely removing it from the database, you just maybe put a deleted at attribute on those records, and you keep them in the database. So that's one solution. But really what you need to think about here is when you separate your front-end team and your back-end team, and your front-end service and your back-end service, the communication about the interface between those two services becomes way more important. So you need to either document that or communicate that or test that using integration tests. So I would argue again that this data loss would not have happened if this were a monolith. I probably would have been doing the front end work in addition to the back end work. I would have known, oh, I better not send strings or the back end won't know how to look it up. So I would argue that the microservice architecture contributed to this problem. It's really about the communication of the interface between two services. You could make sure that those two things are clear by running tests across the boundaries of those two services, by using continuous integration to do those tests. Now, all of these examples that I've given you today, they're not meant to dissuade you from using microservices. I'm definitely not saying don't use microservices. But I am saying maybe they're not the answer to all your problems. They're really a trade-off. Okay? When you're using microservices, you want to make sure you don't create knowledge silos between your teams. Yes, you've separated your teams now, and they don't have to work on all of the application logic. But you really need to make sure they're still communicating, and make sure that your services can communicate clearly between each other by having a clear interface. You also want to make sure that your test suite is testing across the boundaries of your services. Definitely use continuous integration. That's a great tool. But just running the tests within one service will not ensure that you don't break those boundaries between the services, break those contracts. And really, my takeaway from microservices is, can your team, can your organization afford these trade-offs? Can you make pull requests to 3 different repos to delete a feature flag? Can you communicate effectively across your teams to make sure that you're not breaking somebody else's service? And it's really a trade-off. Is that worth it? Or or do you have so many people you can't work on a monolith? You know, maybe you have too many people working in the code base, and that's more pain to you. It's really up to you, and you really need to think about that before you choose or before you move towards microservice architecture. And that's all I have. Thank you. Yeah, it would be great for the recording.
So we are monolithic application base, and we are planning to go to the microservices. Couple of things came out. One is the question, some argue that you can have all the benefits of microservices. Just restructuring your monolithic application and going with Dockers and containers, you can have fault tolerance, you can have scalability, you can have compartmentalization. Your thoughts on that? And I have another question as well.
I think that containers have their own problems. And you may still run into these issues. You still need to have a good ops team who can handle the communication between containers, or at least a person who knows those things. I think there's just another set of problems in the same way. And I think it's just a trade-off, just like anything.
Okay. And the second thing is we have, okay, all right.
You ready for the next one? Okay. I'll be outside if anyone has any more questions, or if you're interested in a shirt, Fastly shirt, or stickers. I have those. Thank you.